The our second lecture on exercise 2.1. In that, the first problem is find the equations of the tangent to the curve x square plus y square minus 2x minus 4y plus 1 is equal to 0, which are parallel to x axis. Now, what is the given curve? X square plus y square minus 2x minus 4y plus 1 is equal to 0. This is equation number 1. So, differentiate this equation with respect to x. X 2x plus 2y dy by dx plus minus 2 minus 4y 4 dy by dx is equal to 0. So taking the dy by dx common from these two terms, you get dy by dx is equal to 1 minus x upon y minus 2. Now it is given that the tangent is parallel to x-axis. As the tangent is parallel to x-axis, any line which is parallel to x-axis having the slope 0. So slope of the tangent must be equal to 0. So the derivative must be equal to 0. So you get x is equal to 1. So x is equal to 1. We will put it in the equation number 1. We get quadratic equation in y. So after simplifying, we get two roots, y is equal to 0 or y is equal to 4. So what are the points? So these are the required equations of the lines, which are the required equation of the lines which are tangent to the given curve. Y is equal to 0 and y is equal to 4. I just draw the figure of this given curve. This is the circle, equation of the circle, and these are the tangents. Y is equal to 0 is nothing but x-axis, and y is equal to 4 is this line. And perfectly these are the two tangents which are parallel to x-axis. The next equation is find the equations of the normals to the curve 3x square minus y square is equal to 8, which are now parallel to the line. We want to find the equation of the normals which will parallel to this line. So which will parallel to this lines means we must have x plus 3y. Okay, in normal equation of the normal, only the c will be different. Take the given curve, differentiate with respect to x, find dy by dx. It is 3x upon y, equation number 1. Now it is given that the normal is parallel to this line. So what is the slope of this line? Slope of this line is minus 1 upon 3. As slope of this line is now minus 1 upon 3 and normal is parallel to this line, slope of the normal will also minus 1 upon 3. So as the slope of the normal is minus 1 upon 3, what will be the slope of the tangent? It must be equal to minus 1 upon slope of the normal, which is equal to 3. So this dy by dx must be equal to 3. That means 3x upon y is equal to 3. So from this equation, we get x is equal to y. So the point at which we want to find the normals, the coordinates of that point having x coordinate is equal to y coordinate. So we will put that in the given equation and we will get the 2 points. Y is equal to plus minus 2. But we know that x is equal to y. So we get the coordinates 2, 2 or minus 2, minus 2. So the first equation of the normal at this point is y minus y1 is equal to m times x minus x1. Similarly, y minus y1 is equal to m times x minus x1. Now we know that the equation of slope of the normal is minus 1 upon 3 and these are the 2 points. Put those values in this equation, we will get x plus 3y is equal to 8 and x plus 3y is equal to minus 8. So these are the required equations of the tangents, normals. These are the required equation of the normals. Now, if the line y is equal to 4x minus 5 touches the curve y square is equal to ax cube plus b at the point 2, 3, find a and b. What they are saying, this line touches to this curve. That means they are saying that this line is tangent to the curve, but they are not using the word tangent. What they are saying, they are saying touches. Touches means it is tangent to the given curve. Now this point p of, let p be the point 2, 3 be the point on this curve. Okay, and the given curve is y square is equal to ax cube plus b. Look at this. Suppose this is the figure. This is the curve. Y square is equal to ax cube plus b. Then this is the line which touches the curve at point P. Then this point lies on this curve, so it must satisfy the equation of the curve. So we will put the coordinates of this point on this in this line. 3 square is equal to 2 cube a plus b, that means 8a plus b is equal to 9. This is our equation number 2. Now this point also lies on this given line. Okay, from that also we can find the equation in terms of a and b. But now this we will differentiate this equation with respect to x. So 2y dy by dx is equal to 3ax square. So dy by dx is this. Okay, so we will find the value of the derivative at the given point 2 3. That means we are finding the slope of the tangent to the curve at this point. It is comes out to be 2a. But what is the tangent at this point? It is y is equal to 4x minus 5 and its slope is 4. So this 2a must be equal to 4, which implies a is equal to 2. So we will put this a is equal to 2 in equation 2. We get the value of b as minus 7. I told you the another way, as this is tangent to the given curve at this point. So this point lies on both the equations. Okay. Now the next, a particle moves along the curve 6y is equal to x cube plus 2. Particle moves along this curve. Find the position on the curve at which y coordinate is changing 8 times as fast as x coordinate. What is the curve? 6y is equal to x cube plus 2. Differentiating with respect to x, we get the 6 dy by dx is equal to 3x square dx by d. So it is given that the y coordinate is changing 8 times as fast as the x coordinate. That means rate of change of y is 8 times the rate of change of x. Okay, now this x1 y1 lies on this curve. X1 y1 lies on the given curve, so it satisfies the equation of the curve. So 6y1 is equal to x1 cube plus 2. So also we will put the same in the second equation in terms in the derivative. 6 dy by dt at x1 y1 is equal to 3x1 square dx by dt at x1 y1. Now from equation 3 and 5th, this is third equation and this is fifth equation. What you get, 6 times 8 into dx by dt at x1 y1 is equal to 8 into dx by dt at x1 y1. So what is dy by dt at x1 y1? It is 3x1 square dx by dt. So after putting those values, you get 3x1 square is equal to 48. So x1 square is equal to 16. So what is x1? Plus minus 4. When x1 is equal to 4, we get y1 11, and the corresponding point is 4 11. Now when x1 is equal to minus 4, we get the second point minus 31 upon 3. So these are the 2 points on this given curve. These are the 2 points on this curve whose y coordinate is changing 8 times as fast as the y coordinate. Okay. A spherical soap bubbles is expanding so that its radius is increasing at the rate of 0.02 centimeter per second at what rate the surface area is increasing when its radius is 5 centimeter. Let R be the radius and A be the surface area of the spherical soap bubble at time t seconds. Okay, R is the radius of that spherical soap bubble and A is its surface area. Then what is this formula for to find the surface area of the sphere? It is 4 pi r square. So dA by dt, rate of change of area with respect to time, is 4 pi 2r into dr by dt. It is given that the rate of change of its radius is 0.02. That means dr by dt is 0.02. Okay, given that rate of change of the radius is 0.02 centimeter per second, and we want the rate at which the surface area is increasing when its radius is 5 centimeter. So r is equal to 5 centimeter. Use these two values in this equation, you get 8 pi into 5 into 0.02. After multiplication, you will get 2.514. Thus, the surface area of the soap bubble is increasing at the rate of 2.514 centimeter square per second. The surface area of a spherical balloon is increasing at the rate of 2 centimeter square per second. What rate the volume of the balloon is increasing when radius of the balloon is 6 centimeter? Let R be the radius and A be the surface area and V be the volume of the spherical balloon at time t seconds. Okay, so what is the surface area? 4 pi r square. Okay, differentiate with respect to t. dA by dt is equal to 4 pi into, we have to differentiate with respect to t, so we have to firstly we differentiate with respect to r, then differentiate r with respect to t. Now it is given that the rate of change of the surface area is 2 centimeter square per second and the radius is 6 centimeter square. Use that information, you will get dr by dt, r into dr by dt. You can also find the value of dr by dt only in terms of 1 upon 4 pi r. Now we want to find the rate of change of the volume. So what is the volume of the spherical balloon? It is 4 by 3 pi r cube. Differentiating with respect to t, 4 by 3 into 3 r square dr by dt. 3 gets cancelled. 4 pi r into r dr by dt. So 4 pi into, what is r? R it is 6 and dr by dt is 1 upon 4 pi. So 4 5 will get cancelled and you will get dv by dt as 6. That is the rate of change at which the volume of the balloon is increasing because here is plus. If the sign is minus, then definitely the volume will be decreasing. So the volume of the balloon is increasing at the rate of 6 centimeter cube per second. If each side of an equilateral triangle is increasing at the rate of root 2 centimeter per second, find the rate of increase of its area when its side of length 3 centimeters. Let the side of the triangle be x. Okay, the triangle is having the side x centimeter. So rate of change of increase of its side is root 2. So dx by dt is root 2 centimeter per second. Now let A be the area of the equilateral triangle. Now we have the formula to find the area of the equilateral triangle, root 3 by 4 side square. Use that. Differentiate with respect to t, you get root 3 by 4 2x dx by dt, but dx by dt is already given root 2, so put that value and simplify. You'll get 3 times root 3 by 2. This is the area is increasing at this rate. Okay, the area is increasing at 3 root 3 by 2 centimeter square per second. The age of a cube is decreasing at the rate of 0.6 centimeter per second. There is one cube and the age means side is decreasing at the rate of 0.6 centimeters square per second. Find the rate at which its volume is decreasing when the age of the cube is 2 centimeter. Let the side of the cube is x and volume be v. So given that dx by dt is 0.6 centimeters per second, it is decreasing. So we also can show that it is minus 0.6 centimeter per second. Now to find dv by dt when x is equal to t, what is the volume of the cube? It is x cube. Differentiate with respect to t, 3x square dx by dt. Then what is the volume rate of change of the volume at x is equal to 2? It is 3 into 2 square into 0.02. So dv by dt at x is equal to 2 is 7.2 centimeters cube per second. That means the rate at which its volume is decreasing is 7.2 centimeter cube per second. This is the example from exercise 2.1. Now we will stop here.